Awesome. Well, I'm going to get started. Thank you so much, everyone, for coming out today. This is hopefully the first in a series of 6 sessions around uh, Kubernetes and getting a little more in depth with it. Before I get started, just wanted to go over the code of conduct. Women Who Code is an inclusive community. We're dedicated to providing an empowering experience for everyone who participates in or supports our community. And that's regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, political affiliation, or preferred programming languages. Our events are intended to inspire women to excel in technology careers, and anyone who is there for this purpose is welcome. We do not tolerate harassment of members in any form. Our code of conduct applies to all Women Who Code events and online communities. And you can read the full version and access our instant report form at womenwhocode.com/code of conduct. So, well, and so with that, who am I? My name is Camille Clayton. I'm an engineering manager at a large company. My focus and area of management is in Kubernetes infrastructure. What that means is day to day, I'm in charge of managing a team of about 7 engineers, working on about 50 production clusters across 3 continents. It's an interesting challenge in the last about 2 years. Before that, I've been in infrastructure or network focused engineer at a couple different companies. And I've also done, just help desk for a cable company way back. At Women Who Code DC, my role is a director and as well as the Cloud and DevOps lead. I've been a Cloud and DevOps lead since 2019. Realize I'm coming up on 5 years doing that. And then I've been a director since midway through 2020. When I'm not working or helping with an event like this, I'm probably somewhere reading about virtualization, high performance computing, or catching me at a loud concert. Cool. As this is part of a series, basically what we're looking for everyone to come out with is a high level understanding of Kubernetes, its development history and impacting cloud computing. One thing I want to call out is the abbreviation K8s or K8s. You'll hear Kubernetes or K8s referred to a lot in that manner. There's sort of an industry, not standard, but just habit of shortening where you take the first letter and the last letter and then give it a number in between. You'll see this for internationalization, which I think is I18N. You might see it for accessibility, which I think is like A12S. I could be wrong there, it might be A9S. But just in case you see K8s in anything I link or share in any of those sessions, we're just talking about Kubernetes. Sorry about that, I need to fix the chair. So other goals for the series is the ability to build a development K8s cluster on your local machine. We'll be going through that in our next session. And we'll be using specifically the tool called Minikube. Anything I mentioned in this session, we'll go through the installation of in addition to using that tool. So if you've never used Minikube or Terraform or anything that might get mentioned, we'll go through that. On a future site, I'll talk about some of the things we're not going to dive into. After we get Minikube running, we'll get a basic app or two running on side of your K8s cluster. And then in later sessions, we'll go through and highlight key security and networking concepts, as well as file access and restrictions in K8s, as those are common things we see. Um, just needing additional training as the models of work for those concepts are just a little bit different than if you're working on a single node system. Things that are helpful to know in advance before diving into any of the workshops. Once again, you do not need to be an expert in any of these, but if you haven't used them recently or if you've never used them, it might be good to take a look at some Linux and Bash basics. Getting a basic Linux shell up and running and using the Bash terminal is very helpful. If you have a Mac, you'll have a terminal which uses ESH, which is a sort of sister or next level of tooling built on top of Bash. Other things to be aware of are Docker and containerization basics. An IDE or another way to interact with code on your desktop, as we'll be writing some pretty basic code, mostly in a formatting language called YAML, or yet another markup language. My preferred editor is going to be Visual Studio Code for any of these workshop sessions. It's a free open source product from Microsoft. So there's no cost entry into any of these items and tools. One of the nice parts about using Minikube is that it's also both open source and will run on a desktop. And then Terraform as well. Terraform is a product from HashiCorp. There's recently been some licensing changes, but there shouldn't be any concerns for this kind of demo. Okay. Two things I wanted to call out that we won't dive into in any of these workshops. We will not be covering cloud managed K8s solutions. This is something I would love to dive into in the future. Would hopefully be able to work with one of the providers and get some credits. And then Docker Swarm, HashiCorp Console, Rancher RKE. These are other ways to orchestrate containers that are not Kubernetes. Oh, Rancher should be K3s, not RKE. The RKE product does use the whole Kubernetes cluster. Well, this is a good stopping point if there's any questions about sort of technologies we will be using in these sessions. Give a second. Cool. Moving along. So why Kubernetes is important? Kubernetes started in about 2015 as a nascent project inside of Google to modularize their deployment system called Borg. And so out of that sort of little group in Google, the Kubernetes open source project started in 2015. And in 2015, going from 0 users to 2022, there are millions and millions of deployments on Kubernetes. And in 2022, they estimate over 1.8 billion USD was spent on Kubernetes and Kubernetes related services. And the CNCF is estimating that to grow to over 7.8 billion by 2030 if adoption continues to increase in that manner. Over 50% of Fortune 100 companies have adopted Kubernetes, and over 78% of small and medium businesses have adopted for container management. For a technology that's existed for less than a decade, that is wild. Like similar penetration for Windows didn't happen till the late 90s. It's sort of wild how common this paradigm has just sort of taken over the landscape. I remember I don't know, probably about 2018 was the first time I tested and played with Kubernetes, launching a very small cluster similar to Minikube. And it's went from, we might use that in like 5 years to, oh no, we're pivoting now. One thing that makes Kubernetes unique is it combines a lot of technologies under the covers that have been very common in both on-prem and cloud data centers, and allowed you to provide a much more seamless development experience. And part of how that adoption has been so readily available is the backing support of the CNCF, or the Cloud Native Computing Foundation. This is the foundation for managing open source projects that came out and was birthed from the Linux Foundation, who have been doing that for about 20 years, helping to shepherd the Linux operating system and related code bases. And they estimate in 2023 that Kubernetes has 92% of the container management market share. And so, like, if you go back to like 2017, containerization started around like 2011 with Docker and Docker Swarm. You saw that product come out in like 2013. And Docker Swarm, I think in like 2015, had about 80% of the container management market share. And the shift post 2017 from Docker Swarm to Kubernetes has been wild. And then at the same time, Kubernetes has become a nexus of energy of legacy modernization, not just moving apps from, say, like an on-prem data center, but containerizing it and moving it to Kubernetes in like one swift move. That process is called lifting and shifting. And then other people are designing apps to take advantage of Kubernetes' unique capabilities and are developing it natively for that technology. And going back to like the key thing is all of this technology is free at heart. So the code base is 100% open source. You can dive into it. There are a number of what they call SIGs, or community of practices, where you can get involved on a specific niche to help move it forward, as well as ask questions. There's a CNCF and a Kubernetes Slack that's full of just some of the smartest people in the whole world that you'll be able to interact with. I will have links in the last slide. So when I share the slide deck, all those links will be there. And yes, the slide deck will be available after the event. Any other questions before I hop on to the next slide? So how does Kubernetes impact us? If you are building a modern development platform, it's very likely to rely on Kubernetes. And if it doesn't rely on Kubernetes, it's very likely to be integrated and providing access or providing the ability to deploy to Kubernetes. Understanding how Kubernetes and similar underlying systems work will really help you to develop and update applications to take advantage of its unique skills. Something that I want to call out with Kubernetes is like parallelization. So ability to work on multiple things at once is a lot easier in Kubernetes. Its whole design is about scheduling multiple workloads at once. So many applications can run inside of a Kubernetes cluster. Like in my largest cluster, we run over 2,500 unique applications. There is self-healing and readiness via health checks built into the Kubernetes system. So you can program a part of your application to talk to the Kubernetes control plane. And if that little part basically says, hey, I'm not healthy right now, I'm not working right now, or it's unreachable, The Kubernetes system will know and monitor that for a specific period of time. If it's unable to reach it, it'll eventually add a new pod or bring up related resources, and then we'll quietly terminate that application in the background. And because you can run many copies of an application simultaneously, one app going down won't impact your customers' clients' ability to access your systems. It's really amazing in practice, and we'll dive deeper into that in a future session. Other things to think about is somewhat simpler, but making sure you're using the most modern of tooling and libraries. We all build on foundational tools when we're designing applications. So things like making sure you're using a newer version of Java or a newer version of Node.js that are Kubernetes and containerization aware can provide you additional performance capabilities without having to actually change your code beyond updating that library. Cool. Kubernetes is written in Golang. And like I said before, it's open source. And so every bit of it is on GitHub. All of the active development is in a public GitHub repo. And so, or many public GitHub repos. So you can get as deep into the code base as you want. So like, say you're working and you're hitting some performance issue, you track it back, it's not related to your application. You can actually go in and put in an issue in the Kubernetes repo and potentially work with the core engineering team to help duplicate and resolve that. It's wild that something this critical is that open. So beyond that, like the monetary impact is really key to understanding that this is sort of a quiet storm of a technology. It's not disruptive in the same way as like the overall concept of the cloud, but it is disruptive in the sense that it's over 5% of annual IT spend globally. And so, 1 out of every $20 in the world is going towards Kubernetes or Kubernetes services. And so, like, even if you're not using Kubernetes today, the likelihood of you interacting with a Kubernetes system in the future is very, very high. As you get further in your career, you will always experience new technologies, and it's great even if you don't end up building or managing Kubernetes systems to understand how this might impact you and be prepared for if you do end up in a role where you're interacting with it on a day-to-day basis. Any questions before I hit the next slide? So now that we talked a little bit about where it exists in the world and marketplace and how it might impact us, what is Kubernetes? And so I like to describe it as a system which allows for highly available, fault-tolerant, and extremely scalable applications to be deployed. There's a lot to unpack there, but the heart of it is because the system is designed to handle all of these functions, each individual application doesn't have to reinvent the wheel. So high availability as a concept is ensuring your app is available essentially 24 hours a day, 7 days a week, 365 days a year. In systems engineering, there's the concept of measuring availability in terms of nines. 1 9 means your system is about 90% to 98% available. Two nines means your system is achieving 99% of uptime. I think, if your system is up 99% of the year, I think like you can be down about 2 days out of the year, so about 48 hours. When you get into three nines, 99.9%, you're getting down into the hours of downtime a year. Not every system needs three nines, four nines, five nines. But like in practice, like our Kubernetes clusters were getting more than 99% availability without having to do any additional engineering to ensure that. And that's a great feeling compared to other engineering exercises for predecessor technologies, like in my case, working with VMware or just local Linux systems on RAID arrays. For mission critical systems, choosing Kubernetes as a technology gives you a great runway compared to having to, by default, spend engineering time to ensure high availability in a non-Kubernetes system. Fault tolerance is going back to those health checks that I talked about a few minutes ago. So the Kubernetes system itself has a series of health checks, and its distributed design means there's multiple copies of the core system components. And so not only at the application level, but at the core system scheduler API, all of these components can both self-heal and self-manage. They do things like leader elections. So if part of the system is down, but not all the system, it's able to eventually fix all of the nodes. And then we talk about scalability. So scalability is how large of a system it can manage effectively before you need to think about things like sharding. Kubernetes has been ran at thousands and thousands of very large nodes running tens of thousands, if not hundreds of thousands of pods, which are your individual applications or collections of applications that are working in a coordinated fashion. And it just works like that out of the box. Previously, just trying to get small application clusters of 3 nodes required a lot of custom load balancing logic. And Kubernetes brings all of that in out of the box. So Kubernetes is different from a physical server or virtual machine, as is a system to help run containers on Linux and Windows servers, with the underlying servers also being managed by the K8s control plane. And so the K8s control plane is ultimately like the brain, and it's the first part we'll be deploying with Minikube. If you've used a physical server, you think about your desktop, or if at your job, or say if you have a home lab, you've used virtual machines, you might be running Linux or Windows, maybe even fuss around with BSD or mainframes. K8s is designed to handle both the provisioning of those nodes. So it could be bare metal, it could be VMs, it could be people have gotten encapsulation of Kubernetes on Kubernetes. Lots of interesting ways to like deploy the system and then segment it, but it handles all of that through the control plane, as well as providing access via a consistent API for users and system administrators for the key interaction point of the server. All of your commands are through an API. There's no back end tweaking generally. Once it's booted, everything is an interaction through the API. And then what it delivers is this stable system that enables development teams to spend most of their development time on their applications and a lot less on the underlying infrastructure. Um, if you've ever been called in late at night because your application is down, Kubernetes helps with a lot of that because it'll automatically reboot. Um, I can't count how many times I've been called in my career past midnight and before 8 a.m., where it ultimately went with a blurry eyed, okay, I've rebooted that. Let me know if it fixes in about 5 minutes. The nice part about the Kubernetes system is because of that fault tolerance, because of the high availability, you have significantly less interruptions and negative interactions for consuming systems or end users. There's just less downtime overall. Not that there's necessarily less failures, it's just the system is able to fix those small failures, easy failures, computer glitches without human intervention. Yes, 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 yes. For anyone who is on call, HugOps, um, as an engineering manager, I would still participate in the on-call rotation. So every 2 weeks out of every 2 months is always a fun ride. Cool. Um, so the core design of Kubernetes, you have the control plane, you have etcd, and you have worker nodes. The Kubernetes control plane is a combination of a couple other key parts. This is going to be the API server, the scheduler, and controller manager. etcd is like an in-memory, small, super fast database that is hyper focused on providing the right state for all of your systems. It's a key part of Kubernetes distributed design. There needs to be multiple etcd nodes in a production system, and our Minikube will just be running one. But if that etcd component goes down and is lost, the system will rebuild the state and boot up a new etcd. And then worker nodes are where all of your applications live, as well as any other components that might make up your individual cluster. They run on the worker nodes outside of the control plane, outside of the etcd nodes. Kubernetes is very consistently designed around segmentation. And so everything is containerized or encapsulated in some way to make it so it's reusable, repeatable, and redeployable. You spend a lot less time thinking about specific where applications or where data or where systems live, because as long as it's deployed to your Kubernetes cluster and you have your network routing to it properly, it should be able to reroute to the new location successfully. Not saying that getting to that point in computing has been 70 or 80 years of a lot of network engineering, a lot of network wizardry. But it's fascinating to be living at this moment in this time where it can happen in a blink of an eye. And so diving a bit more into terminology, one thing is just calling out what a node is. So whenever you hear node, it's the internal reference to a system that Kubernetes can run containerized workloads, because a node can be a number of different technologies. It could be a VM, it could be a bare metal server, it could be some combination. You can EKS node groups, so you can run some systems on x86 and some on ARM or various combinations of other platforms. If you ever see node in any of the documentation, they're just referencing a place where Kubernetes can run workloads. Cool. Any questions before we dive into the next slide? Cool. So In future sessions, future workshops, we're going to aim to focus mostly on the provisioning of the control plane and etcd via Minikube. This is basically like our first major milestone when working with a local Kubernetes cluster. Apologies, missed that. Once we have our Minikube cluster built, we're then going to be working on getting our first app deployed. So we'll end up deploying the Kubernetes dashboard app. This is an open source application by the Kubernetes Foundation. It's a great demo application. One of the key things it's going to let us play with and familiarize with the K8s manifests and deployment basics. K8s manifests are once again little YAML files we'll write on our desktop and then deploy to the cluster. And then it's going to tell it to basically like, hey, this is the location where the container image is. And then it'll shoot out to the cloud, grab that image, bring it back in, and then load it up on your local machine. And from there, we can, work on our dashboard and our cluster from a visual to UI, and we can also work with on the kubectl, and we'll sort of play with that back and forth in our first workshop. Once we have that basic app deployed, we have the foundation to deploy additional applications. So, if you have like a Java app or a JavaScript or a .NET app handy, you can deploy that. We can also look at some various open source applications that are available to demo and deploy with Docker. And so once we have the cluster working, then we get into a key part of distributed systems, which is distributed problems. So going back to earlier where we have a monolithic app, this is, if you built your app locally and it's running on your computer is functionally a monolithic system. There are multiple components working, but there's no clear segmentation. Everyone can access the file system. Everyone has crashed their computer. That's usually because of either RAM or file memory access collisions. And so as we dive deeper and begin to understand the network and file access and security models, we'll tackle that specifically with Cilium, and we will focus on the network side with Trivy. So all Kubernetes distributions need an active CNI, container network interface. The one that currently, and there are probably about 15 CNIs that are actively being developed either by vendors or open source groups. Cilium is one from open source group. Its main proponent, Isovalent, got purchased by Cisco. But most large active vendor supported tools are building in Cilium these days. And so making sure we're using an up-to-date system is a key part. What Cilium does is act sort of like a traditional firewall or network switch. If you have a modem at your house, it usually also bundles in a firewall. And so like if you wanted to dive in, you could play around. Say you did not want anyone in the house to be able to watch YouTube. You can go in there and block youtube.com. And similarly, we can do that with Cilium to manage traffic. Cilium also allows us to open and block access between various pods and namespaces so that data can only flow in certain directions within the cluster. And as an added bonus, if we have time, we'll take a look at their Hubble UI. And that allows for some visualization of traffic. If we have time today, I might peek on their site and show some of the demos of that. So beyond networking, your next step is your system is alive and it could access the internet, which is not always a great thing. And so with access to the internet, with access to multiple systems running simultaneously within the same larger system, you have security concerns. And a great tool and starting place inside the Kubernetes ecosystem is an open source product called Trivy. The original tool is just called Trivy, and allows you to scan running container deployments inside your Kubernetes cluster. A container can have many layers, and so there can be issues at all the layers, some layers are just one of the layer, and Trivia will help you identify that and help you to provide like operationalized ways to resolve it if those are publicly available. One key concept inside DevOps, and you'll often hear it as shifting left. So earlier into the development lifecycle is a push within security. You might hear it called as DevSecOps, where you're making sure to basically be practicing security as sort of daily hygiene and less of a annual or semi-annual or monthly practice. Security needs to happen every day. And so with taking that in mind, I think it's a key entry point for understanding the whole ecosystem is making sure you do have some security basics. Cool. Before diving into next slide, just want to give a little bit of room for questions.
I have a quick question. And this might be a little late in the talk for this question, but I'm going to ask it anyway. And this also might be slightly a naive question. But how do you come to the decision of like, okay, we need something like Kubernetes? And like, how do you know when you're at that point is my first question. And the second question is maintaining like the Kubernetes cluster, for lack of a better word, cluster is appropriate, or yeah, is
Yeah.
that how like intensive is it? Like, would a single person be able to do it, or does it require like more people, like a team?
One person can definitely maintain a Kubernetes cluster. Um, I guess for a reference point is we routinely have 5 engineers managing 50 clusters, so about 1 engineer for every 10 clusters. And then our engineering team at work, so we have 7 engineers, including myself, supporting one of our engineers is newer set for the most year. It's been 5, for most of the last year and a half, it's been 5. Uh, supporting 1,200 developers, which then deploy 5,000 applications. It's very scalable. So generally, when we set up Kubernetes cluster, and we'll dive into that in our first workshop, we start with using repeatable infrastructure as code practices. And so tapping into that is sort of a hidden superpower in addition to Kubernetes itself. Leveraging an infrastructure as code platform like Terraform or AWS CloudFormation or Chef or Puppet. There are a number of ways to deploy infrastructure via code. But that revolution that's happened in the last 10 years of DevOps has greatly simplified day-to-day management. So to like perform like a cluster upgrade is usually just updating a few lines of code and then hitting play on a CI/CD pipeline. And so we're shifting how operators, system administrators work towards a more development style of working. And then we're also providing interfaces that work very similar to programming and designing like an application. And this can run any language as long as you can build a Linux or in some cases a Windows container image. So Kubernetes itself does not care about the underlying application language. Where I have seen friction, where we do have friction, is in major cluster upgrade cycles, where we need to interact with development teams to get them to update the sort of wrapper code that allows you to get a Kubernetes deployment. This can be via Helm, it can be through raw K8s manifest, it can be through the raw K8s API, it can be through Flux, Pulumi, Argo CD. There's a lot of different ways to deploy to Kubernetes, and making sure everything matches, even if it's just a 1 or 2 line change, can be pretty hard when you get to a scale of 5,000 places where everything is wrong. Not wrong, it just is no longer right for the newest platform version. Kubernetes is getting, as it matures, is getting better about letting changes be a little gentle. I say this as we're currently just wrapped up about 2 hours ago our 1.25 production deployment. I love that, Catherine. Catherine in the chat says how they would answer is depends, and it can sort of suck that there isn't a clear answer. You have to look at your current infrastructure and what your business needs to decide when or how you're going to migrate to Kubernetes. There can oftentimes be better implementations via Lambda, plain old EC2 instances. K8s, they say K8s is a great resource for hosting apps, but not the only one. And they personally enjoy Kubernetes, and I think it's a fantastic tool, but there are many. Yes, Kubernetes is not the be all end all. I'm just coming from the perspective of wanting to share sort of what I've learned in like the last 3 years of working with Kubernetes focused teams. There was a long time where I loved Lambdas and serverless and was obsessed. Like I got to put a serverless sort of weekend version of PagerDuty into production during a budget crunch at a role. So there's lots of interesting ways to deploy applications that are not Kubernetes. My recommendation is when you're trying to figure out how to run tens, if not a couple dozen applications in a highly available fashion, you might want to look at Kubernetes. If you're not at that point, if you're not at that place, it's probably overkill. I would not start day one. Like if you're working at a brand new company and you have one application and be like, this needs to run on Kubernetes. Now, for where I work, Kubernetes is absolutely the right choice because of the distributed nature of all of our engineers, all of our developers, and stuff needing to run 24/7 to support users in every country. The teams that are not doing Kubernetes and are trying to do the scalable things that sister teams that are on Kubernetes are struggling. That's sort of my insight on that front. Cool. So before just open the microphones, it's been a great pleasure to give this overview. I apologize, I think I deleted one slide. Basically, we're going to have 5 more sessions over the coming months. And 2 of those are going to be hands-on workshops where we're going to be typing. I'll work on breakout rooms. And I'll have GitHub repos for how to get everything built via Terraform. And then we'll have, I think, 3 more just sort of seminars like this where we'll cover specific topics like networking and security. Cool.